In this lecture, we are going to discuss arithmetic coding. So, arithmetic coding generates non-block codes. What do I mean by non-block codes is, let's refer to the previous slide in which we have discussed Huffman coding. So, in Huffman coding, what do? We assign a code to a particular symbol. Like for A2, 1 is the code. For A6, 00 is the code. For A4, 0100 is the code. So a fixed code is assigned to particular symbol that is called block. So that is why they are called block codes. Now this is not the case in arithmetic coding. In arithmetic coding, one-to-one correspondence between source symbol and code words does not exist. That means there will not be a single code for a single symbol in the arithmetic coding. So what we do actually in arithmetic coding, an entire sequence of source symbol is assigned a single arithmetic code word. That means a message is there in which sequence of source symbols will be there. That message will be assigned a single arithmetic code, and that arithmetic code will be in between 0 and 1. So how do we do arithmetic coding? Let's look at it with an example. So suppose we have a source which has these four symbols A1, A2, A3 and A4. The probability of occurrence of each symbol is 0.2, 0.2, 0.4 and zero point 0.2. Now suppose we want to use arithmetic coding to encode this message or the sequence of symbols that is given by this, that is A1, A2, A3, A3 and then A4. So this is the five symbols which we want to encode using arithmetic coding, and we have these four symbols with the probability of occurrence of these symbols is this one. Now in first step, what do? We divide the range 0 to 1 range into in accordance with the probability of occurrence of these symbols. So probability of occurrence of A1 is zero point 0.2. So 0 to zero point 0.2 is A1. Then zero point 0.2 to zero point 0.4 is A2. Then since probability of occurrence of A3 is zero point 0.4, so zero point 0.4 to zero point 0.8 is A3 and zero point 0.8 to 1. This is A4. So this is how we divide this range in accordance with the probability of occurrence of these symbols. Now we look at the message. In message we have first symbol A1. So the range of A1, that is 0 to zero point 0.2. Its height will be made equal to this height, and then this range will be further divided in accordance to the probability of occurrence of these symbols. So again it will be divided into four subranges, and the range of each uh, this variable will depend on the probability of occurrence of each symbol. Now 0 to zero point 0.2 is divided into four these ranges, and the first corresponding to A1, the range will be 0 to zero point 0.04. For A2 it will be 0.04 to zero point 0.08, and since A3 has probability of occurrence twice the remaining symbols, so it will have range twice of these symbols. So it has the range 0.04, so it will have the range 0.8. So 0.8 to 0.16 is the range for A3, and 0.16 to 2 is the range for A2. Now the next symbol here we have is A2. Now the range of A2, that is 0.04 to 0.08. Its height will be made equivalent to this height, and then it this range again will be divided in accordance to the probability of occurrence of these symbols. So the first range we will get is 0.04 to 0.048. Then second will be 0.048 to 0.056, and then uh, third will be from this to 0.072, and last will be the fourth range. Then the next symbol we have is A3. So this A3 range, that is from 0.056 to 0.072. This will be again heighted with the same this height, and then it will be divided in accordance with the probability of occurrence of these symbols. So this will be range for A1, this will be range for A2, this will be range for A3, and this will be range for A4. Now again the next symbol is A3. So the range of A3, this is 0.0624 to 0.0688. This will be again heighted with the same height, and it will again be divided into four ranges in accordance with the probability of occurrence of these symbols. So the first range we get this, second here, and third here, and fourth will be from 0.06752 to 0.0688. Now the last symbol is A4. So the last range we have got is this one, that is from 0.06752 to 0.0688. Now this message or this sequence of symbols can be represented by any number in between these two numbers. It can be represented by any number which falls in this range. So that is called arithmetic coding. So the final symbol will narrow the range to this range. Now any number within this subinterval, for example 0.068, 0.068 is in this range, and that can be used to represent this message. 0.068 can be used to represent this message. Now since we are using three decimal digits to represent this message. Now, three digits are there 0, 6, and 8. So, three digits we are using to represent a 5 symbol message. So, the message was A1, A2, A3, A3, and A4. So, this it has 5 symbols, and we use only 3 digits to represent this message. So, if I want to find the decimal digits per source symbol, then it can be given by 3 divided by 5, since total number of symbols are 5. So 3 divided by 5, that comes out equal to 0.6 decimal digits per symbol we are using. And if we find the entropy of the source, that comes out to be 0.5858 decimal digits per symbol, or 10 array units per symbols. So here we can see that we have good efficiency of this code uh, in reduction of coding redundancy. Now we have two factors which bounds the arithmetic coding. One factor is, since in the Huffman coding, we did not had to use any end of the message indicator. But here in arithmetic coding, we have to use an end of the message indicator. So this is one limitation, that is one bound. And another bound is the use of finite precision arithmetic. So you see, we have to go to the arithmetics which is in the decimal numbers, and that is quite small numbers. So if we go for more number of symbols in the same sequence, then this will further be divided, and we will get more decimal digits after this decimal point. So the precision is another bound of this arithmetic. So hope this arithmetic coding is clear. That's it for this lecture. We'll meet